Hello everyone. I hope you can hear me. Can you hear me? Yeah, let me be sure we can hear. How was our day? Oh, cool. That's nice. Yeah, how did you go today? Hope you had a nice time today. My day was quite hectic today. So as I posted on the group chat, um, I went to Nigeria Energy Summit, which was quite very interesting. And honestly, it took all of my day. Right, I literally just came back, right, and I had to quickly set up and all of that. Right? So that's why we had a delay in um, broadcasting this time. Okay, so but would I mean yeah, it was a nice time. So it continues tomorrow. If you have time, you can as well, but you're not going tomorrow. And I just wanted to attend it today. It started yesterday, today, and then they're going to round up tomorrow. So if you are interested, you can also join tomorrow. All right. So without wasting so much time, we can just get started. Right. So if you have any question, anything that is not clear, just drop it on the chat. I'm going to see it, and we can get started immediately. Right. So yeah, let me share my screen. I hope you can see my screen. Is my screen visible? Kindly confirm my screen is visible, please. Why do we have few number of people joining the call? I mean, compared to the number of persons that we have on group chats. I think we have to start kicking people out. What do you guys think? Seems to me like a lot of people are not serious. And that's why I actually had to move people from Telegram to WhatsApp because I just wanted to be sure people, a lot of people, please don't give them off. A lot of people, when they see stuff, they just click it and, they just register. You understand? I don't know why. I mean, I do it sometimes also. All of a sudden, I don't have time to even do that kind of stuff. But I think this is very interesting, right? Honestly, the worth of this training is if you really want to get the worth of it, right? Just go online and check. I'm not saying people that will just teach you one thing, and then you are now a solar installer. No, I'm saying that the curriculum, right, that NEMSA approves, right, NET approves, right, if you want to get it, you're not going to get it anything less than 250,000 naira. And I'm not kidding. I can give you links if you want to go check them out. So I think because it looks like I'm not really hyping the worth of the course. A lot of people don't really think it's important like that, yeah, but it's fun. I pray, one or two persons, right, get to do something with it. I'm not expecting so well. I just want us to know that the fact that it's free, right, doesn't mean I'm giving you something that's cheap. I'm not giving you something that's cheap. I'm giving you years of experience. I'm giving you years of learnings. Maybe I'll do a little bit of background introduction of myself so that you know that I'm not just it's not somebody that does not have work. You understand? Like I said, I just got back from Nigeria Energy events that I went to today. Um, I'm a very busy person also. So yeah, so but there are points where you feel like money is not everything, and you just want to contribute your quota, right? And honestly, that's what I'm doing. I believe in giving everybody a fair chance. You understand? I believe in giving people opportunities, and that's what I've done all of my life. Right? So this is no difference. I just hope two persons or one person will even utilize what they're going to get from this training and you really practice with it, right? For some of you that even live in Lagos, I can call on you to go out with me for installations. Even if you live outside Lagos, there are installations. I work with a company that we produce think I said that on the group chat already. We produce scalable energy products like power stations. I'm the one that does the design and the construction. You understand? I build it. So sometimes we have order outside Lagos, and we needed, a competent solar engineer to help do the installation. And sometimes we're just stranded. So some of you are outside Lagos. I will call on board with you once I know that you really understand this stuff and you know how to do it. We are going to interact on phone. We're going to, even if you have to do video call, for you to even you know carry out the installation, just to let you know that it's not hard. So you understand. So yeah, it's anything can happen with what you're doing. So I really want us to take it very seriously. I really want us to be serious about it, please. Okay. So let's not waste so much time. Let's just get started immediately. So yeah, um, my name is Victor again, and I am the founder of VOAL Technology. For now, we basically deal with solar servicing and training. That's all we do for now. Installation and then training. That's what we do for now. So launch out another part that we do, which is going to involve um, um, the commercial aspects. Yeah, we have a lot of solar products that we 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 can offer. So yeah, we're going to get all of this information as time goes by, so that where you can buy original products, original solar products, because I won't lie to you, there are a lot of fake products out there. I mean, there's a lot. You don't want to go and waste millions and um, to go buy solar products. But please don't get stranded again when next to an installation. Okay. Thank you, Samuel. All right. So, there's a lot of fake products out there, and you just want to be very careful. Okay. So, yeah, we have a lot of distributors that we partner with. So, we're going to be launching the e-commerce side of the website very soon. A lot of those products will be displayed right here. Okay. So, yeah, you can make your order. You can, tell people to, they can be sure that they are getting original products direct from the manufacturers. Okay. So, yeah, we're going to launch that very soon and all of that. But for now, we're focusing on servicing and training, right? So, and training is what we're doing tonight. So, yeah, I also am a co-founder of Tubing Energy. You can look it up. Tubing Energy. We are an energy company. Recently, just delved into solar products. Initially, we were working on mini grids, right? So yeah, I'll talk about mini grids towards the end of this course also. So yeah, we're working on mini grids, and we had some issues with uh, regulations with distribution companies that manage electricity distribution in Nigeria here. So that's why we stopped that, and we had to take on another. And beside that, we have some other products that we do and all of that. So yeah, I'm the chief technical officer there, and I'm responsible for the designing and the construction of some of our energy products. Okay, so I don't only do electrical, I also do electronic. Right. So as a matter of fact, I studied electrical electronics engineering in school. That's yeah, I had ND. That was as far back as 2015, 2016, 2017. And since then, I've done City and Guilds, Electrical Electronics Engineering. I did level 4, and I also did Advanced Diploma, that's level 5, in Electrical Electronics Engineering. All right, so yeah, I've done a lot of projects, right, from installations to designs, marketable products. Okay, so excuse me, let me quickly fix this stuff. All right, sorry about that. I need to get my laptop stand. All right, so what was I saying? So yeah, I was talking about the fact that we've done a lot of product. Um, we still have a lot of products that we are yet to do and all of that. Okay. So that's so much about me for now. We'll continue the rest later on as we get familiar with each other. All right. So today we're just going to be talking about the fundamentals of electricity. All right. So this is very very important when you're dealing with solar systems, right? You can't say because I did not do physics in school. No, you have to, even if you don't know anything, right? You have to understand these basics. Very important. Even if you did not do anything, if you do not know anything, you don't care about anything else in engineering, you have to know this. Okay, so you have to understand when somebody talks about current, you have to know what does current mean. When somebody talks about voltage, you have to understand what they mean. When you talk about electricity generally, you have to be able to say something about that. All right, so and that's why we're considering this. It's very important. It's very important. There are two formulas that you have. You will never forget them. I'm going to teach them in the most simplest way. Even though you have learned them before, right? It's going to be very straightforward and you won't forget them again. Because you would always have to work with them in solar installations and design, right? So basically, this in this module, we're just going to be focusing on electric charge, current, voltage, resistance, power. We're going to be focusing on this. anybody hear me? Can you hear me? Hear me? Am I audible? Seems like you can't hear me. Can you hear me? Hello, hello, hello. Can we hear me? Oh dear. We should hear now. Okay, cool, cool. All right, all right. Uh, Sorry about that. It was just a little bit of All right. So let's just get started. Let me know if I can go ahead, please. Not audible enough. Okay. Maybe I'll just put it directly on the mouth. Hello, can we hear now? Is it audible now? Is it cool now? Okay. All right. All right. So let me share my screen again, and it's still low. Uh, and my network is perfect, so I don't know why. See my settings. How about now? Let's see if I can increase my microphone. All right. Thank you. Thank you. All right. Yeah. So let me just share my screen again. And so I was saying that they're quite, even if you don't care about physics, right? As long as you're dealing with solar installation, there are some basic formulas you have to care about. And yeah, and there are some basic concepts you must care about, right? So they are electric charge, current, voltage, resistance, power, right? And you have to know them, okay? And I'm going to them down. They are very simple, what we do day to day, and all of that. All right, so let's move on. So, like I told us during the beginning of the class, electricity is the flow of electric charge through conductors like wire, resulting from interaction between charged particles. Okay, so I told us where electron come from. Right, it comes from when you break down materials right into elements, and you break the elements into atom, and then you break down the atom also, you find the electron right here. And I said that whatever you do to make that electron move from one point to another, you have just generated electricity, right? So there are a lot of ways whereby we can do that, right? And it's not within the scope of this class to cover that, right? So one of them is through your generator. And then we also have the solar panels that we're considering today. I mean, in this course. Okay. So basically, electricity is the flow of electron from one point to another, right, resulting from interactions of charged particles. So what do we mean by interaction of charged particles? It simply means that uh, uh, charged particles are the positive charge or the negative charge, right? So what you call plus and minus, right? They are charges. Okay. So electron, right, moves from where he is to go to where the positive is, right? And the positive leaves
where it is to go to where the electron is, right? So they continually have that interaction, and that is why you keep having electricity to flow, right? So electric current is specifically the movement of conductor, right? So when electron move in the conductor, you have electric current. Now, picture electric current to, maybe I should even do this analogy. I'm not sure I can use pen here. It doesn't allow me to use pen. I would have loved to. So consider an analogy where you have a valve. Let me look for it. So all of us are familiar with valves, pipes, right? Most of us have it in our houses. So imagine a tank, all right, a tank filled with water. Let's say your GP tank, where you store water inside, right? And then you connect it through pipes and valves, connect it to your kitchen, your bathroom, your anywhere, right, that you need water to flow from. And then you connect it, you run it into your house so that you can use. Now, that water tank, right, that storage is like what you call voltage, right? So anytime you hear voltage, just imagine a water that is stored in a tank, okay? Just imagine a water that is stored in a tank. Now, that water, right, is just there. At this time, we have locked all the valves, both from the tank itself to anywhere in the house, right? We've locked every valve such that that water cannot flow, all right? So we have locked all the valves such that water cannot flow to any part of the house. Yet, there is water inside the tank, but it cannot flow, all right? There is water inside the tank, but I'm trying to get a perfect image for us. So there's water inside the tank, but it cannot flow. So that's kind of like the way your voltage is, all right? So voltage is just that, stuff, that thing that is there. It's just there, sitting down, not doing anything. You understand? Until you do something, all right? So what do we need to do to make water to flow? All right? We only need to what? Turn on the valve, right? Whenever we turn on the valves, we find out that water begins to flow. Now, that flow of water, right? That flow of water is what you call current, right? Current, the flow of the water, not the water itself, the flow or the flow rate, the rate at which that water is flowing, whether it's fast, whether it's just flowing small, right? Or whether it's, pretty much turbulent, is, my screen is dark. Really? Oh my God, that's true. But I'm sharing. Hi. Seeing the screen right here. Why is it? It should show now. Okay. Yeah. My screen is showing from here. Okay. So let's continue. So the flow of current, okay, the flow of water, it's not showing. Okay, you know what? I will be sharing. I will stop the sharing and then I will try to share again. Okay. I'm going to share again now. Let me show the. Okay, can we see my screen now? Can we see the valves? Really? Ah, that's not the case here. Okay, we can see it now. It's showing. Okay, cool. Okay, thank you. All right. So yeah, we can see the valves here, right? Which am I live now? All right. I believe you can hear me now. So anybody can let us where you last said me because I was just talking. What was the last thing you had said that before the network? Anybody? Who's still following? On the Python. All right. So I was saying I was trying to draw an analogy for resistance. I'm trying to say that the resistance, right, is what is responsible for the flow of water that you have in the valve. Because depending on how much you release or open the or close the valve, the network to be God. Wouldn't understand why the network do all of this. So I was explaining that the amount of water you have in the tank is directly proportional to how much of water will flow through the pipe. So just imagine you have 1 cup of water inside a big GP tank, right? How do you think the water will be flowing? If you even see the flow, say, right? Because I'm not even sure water will flow because that small cup of water inside the big GP tank will not even reach the outlet from the GP tank. So you might not even have any current flow, which tells you that if you have a very small voltage, right, that voltage, depending on the resistance that is presented in the circuit, might not allow current to flow at all, right? So the current that flows is largely dependent on the current that flows is largely dependent on the amount of water that we have in the GP tank. I hope that makes sense. Okay, cool. Sorry. Not to want to be about the network. Just have to manage. Hopefully, you know. So the water you have in the tank determines the flow rate of that water. Okay, which tells you that the current, right? Current is dependent upon voltage. The smaller the voltage, the smaller the current, right? The smaller the voltage, the smaller the current. If you have a full tank of water and you release the valve, you notice that the water will gush out. But when the water is going down, even you will know that the pressure has reduced. You say, go and pump water, or this water has gone down. It's telling you that the water inside the tank is going down and the pressure with which the water is coming out with has reduced. That tells you the water is now low. So go and put on the pumping machine, right? The same way, the current that is going to flow in a circuit is going to be determined largely by the voltage. If you have a low current, right? So they kind of just work hand in hand, right? Yeah. And also, the higher the resistance, right, the lower the current, even if the voltage is 1 million, right? So if you as you begin to increase the resistance, right, the current through the circuit is going to reduce. Kind of like as you begin to close the valve, the flow of water begins to reduce, right? As you begin to close the valve, the flow of water begins to. But if you open the valve completely, water begins to what? The pressure. It gushes out, right? That means if you have little resistance to the path of water, you are going to have a lot of water to flow. The same way in a circuit, if you have little resistance present in the circuit, a lot of current will flow. I hope that makes sense. I hope it makes sense. I'm going to have to make this particular session available for 24 hours, right? Because I know the network is a lot of so that we can watch it and then after 24 hours and so because of the network issues and all of that. Right. So let's continue. Just going to rush through the rest now. All right. So we have a formula right here. Yeah, we have a formula here which tells you that the sorry, so we have a formula here which tells you that voltage, right? Voltage is equals to current multiplied by what? By the resistance. Right? So in the tank, the amount of water, right, inside the tank, the amount of water can be equal to what? The flow rate of water, right? How much of water is flowing through the pipe, multiplied by the amount of resistance, right? The amount of resistance that is in the way of the pipe. The amount of resistance that is in the way of the pipe. That's what that means. Okay. So now this is a very important formula that you don't want to forget. Voltage is equals to what? Current times the resistance. You don't want to ever forget that formula. Don't ever forget that formula. Voltage, right, is equals to what? Current multiplied by the resistance. How we can understand that is to say the amount of water you have in a tank, right? The amount of water you have in the tank is going to be equal to the current flowing, I mean the water flowing, right, multiplied by how much the valve is open, right? So if you have the tank that has water inside it, then you have the pipe, right? You have the pipe that can allow water to sort of flow through it, and then you have also the valve. You have the valve. This can drop water. All right. So you have the tank. The amount of water you have inside this tank is going to be equal to how much you open this valve, multiply that, how much water is flowing through this pipe. All right. So if you open this valve so much, water is going to be gushing out very fast and at a very high rate. And if you quantify that and you multiply it by how much this is open, you're going to get how much of water is here. So if you open this tap completely, all right, and you find out how much water is gushing out, all right, and you do that math, you are going to know how much of water is here. That could have led to that amount of water, I mean, to the flow rate of that water when you take into consideration the how much the valve is open. What I'm trying to say is that if you have If you have a circuit, an electric circuit, let's say a battery, so you have a battery here, right? Most of us are familiar with battery. So you have a battery here, and let's say you connect it to a bulb, right? You also have a bulb. You have a bulb here. So if you connect this battery, let's say to this bulb, right? What you find out is that this bulb begins to glow, right? It begins to glow, right? And that is glowing because now current is flowing from the battery to the bulb, right? So if you multiply the current that is flowing in this bulb, right, multiplying by the resistance of this bulb and also the resistance of this wire, you are going to get how much of energy is stored in the battery. That's what it means. You are going to get the voltage of the battery, right? So that is a very important, what's it called? Formula that you should never forget. Right? Let me just know if you have any questions so far. Let me know. Right? Yeah. So another formula that is very, very important, right, is this one, where power, right, is equals to voltage multiplied by what? The current. The power, all right, of an electric circuit, the power, that means the strength that our circuit we have, is going to be determined by its voltage and its current, right? Now, there are a number of formulas for calculating power, right? But all of them, the rest of the formula are derived from this particular one here, right? But we're not going to go into that. We don't really need that. These are the formulas here. Right? This is I square R. This is one formula here. This is another one. V square over R. All right, but you know, we don't need these ones. We just need to focus on voltage multiplied by what? By the current. That's what we need. All right, that's what we need. So the power formula, right? The power formula. This one is, in fact, if you don't know any other formula, right? In solar design and installation, you must know power formula. You must know. So right from this night, just cram it. That power is equals to voltage multiplied by what? By voltage is given by what? Current multiplied by what? The resistance, right? But out of these two formulas, this is the most important that we're going to be dealing with. All right, so let's move on. All right, so let's do some little calculation. Right. Say you're given 12 volts. Let's say you're given a battery. All right, the battery has 12 volts. Okay? So let's say can be a lithium-ion battery, for instance, or your tubular battery, for instance, in any sort of battery. And that battery has 12 volt of power. Okay, yeah, 12 volt of power. I mean, 12 volt of energy. Okay. So, and then that battery can deliver up to 2 amps of current, right? That battery can deliver up to 2 amps of current. They now ask you to calculate the power of that battery, right? You asked to calculate what? The power of that battery. So how to calculate the power of the battery is to use what? Multiply the, I told us power is given by what? The voltage multiplied by what? The current. Right? So here, you are giving the voltage to what? 12 volts. And you are giving the current to what? 2 amps. So by the time you multiply 12 multiplied by 2, you're going to get what? 24. And that is going to be the power of that battery. So next time if you are asked to calculate the power of the battery, simply look out for the voltage. What's the voltage of the battery? 12 volts. What's the current of that battery? Right? 220 Ah or 100 Ah, whatever it is. Multiply both of them together, you are going to get the power of that battery. Right? Power of that battery. Now, they used to say, what's it called? Power. I'm trying to remember the definition of power. Power is the ability to do work with respect to time, right? So the ability that something have with respect to time is what we call power, right? Is what we call power. So the strength of something, you say that guy is powerful. Understand, right? So the strength of any machine, any material, any electric circuit, right, is its power. power. So please understand that in order for you to get the power of a machine, in order for you to get the power of a circuit, you must know the current rating of that machine, and you must know the voltage rating